Good morning and welcome to the Collaborative on Health and the Environment Alaska Teleconference on Endocrine Disrupting Chemicals, New Directions in Science and Policy with Carol Kwiatkowski of the Endocrine Disruption Exchange. My name is Diana DeFazio, and on behalf of Alaska Community Action on Toxics, I'll be facilitating today's call. TEALASKA is a regional partnership group of the National Collaborative on Health and the Environment. TEALASKA aims to advance knowledge and effective action to address growing concerns about the links between human health and environmental factors. And you can find more information on the websites, the following two websites, akaction.org and healthandenvironment.org. The call will last 1 hour, and except for the speakers, all participants are muted during the presentation. And there will be time for your questions and comments towards the end of the call. A link to a PDF of the presentation slides can be found on our website at www.akaction.org. Just click on the title of today's call on our homepage. And before I introduce our speaker, I'd like to say a few words about Alaska Community Action on Toxics work related to endocrine disrupting chemicals. ACAT was awarded a 4-year grant by the National Institute of Environmental Health Sciences to continue our community-based research partnership with the communities of St. Lawrence Island, Alaska. The goals of this project are to conduct research related to endocrine disrupting chemicals and assess exposures from surface waters, household dust, and traditional foods. And results from the project will provide information necessary to reduce exposures and protect public health. In addition, ACAT has long worked to fix our federal chemicals policy, the Toxic Substances Control Act, to ensure that chemicals are tested and proven safe before they are manufactured. And actually today, we have some big news, which is that the Safe Chemicals Act, which is the reform of the Toxic Substances Control Act, was reported out of the Environment and Public Works Committee to the Senate floor this morning. And this is the first major activity on TSCA in 35 plus years. So that's very exciting news. We hope to make more progress on that as well. And we are also working on state policies to reduce Alaskans' exposure to harmful chemicals currently not regulated by the federal government. You can find more out about all of our work at www.akaction.org. And today, we are pleased and honored to be joined by Carol Kwiatkowski, Executive Director and Senior Research Associate at the Endocrine Disruption Exchange, which is a U.S.-based non-governmental organization founded by Theo Colborn and dedicated to compiling and disseminating the scientific evidence on health and environmental problems caused by low-level exposure to endocrine-disrupting chemicals. Dr. Kwiatkowski joined the TEDX team in 2007, and she created the Critical Windows of Development website tool, a timeline of how the human body develops in the womb, paired with animal research showing when low-dose exposure to endocrine-disrupting chemicals during development results in altered health outcomes. In 2008, she became TEDx's first executive director and now oversees the development and execution of all of TEDx's programs. Prior to working at TEDx, she was an assistant professor at the University of Colorado. Her training in behavioral science began at the College of William and Mary, where she received her BA, followed by a Ph.D. from the University of Denver. And we're so happy to have you with us today, Carol. Go ahead. Would you like to begin?
Sure. Thank you very much, Diana. I'd like to start with a brief introduction to TEDx for those of you who aren't familiar with our organization. If you happen to have the slides, those beautiful mountains you're looking at are the home of TEDx on the western slope of Colorado. And Diana has already described our mission, so I'll just say a few words about how we operate. Our goal at TEDx is to step back and look at the big picture of endocrine disruption. We don't campaign against individual chemicals, and we don't have a particular disease to champion. Our function is to provide the science needed to support the campaigns and initiatives of other NGOs doing that kind of work. We also work directly for and with governmental agencies like the Environmental Protection Agency and the National Institute of Environmental Health Sciences. We work with members of Congress to keep them informed of the latest science. And recently, I was at an academic conference where one person after another, professors and scientists working in the field, came up and thanked me for our Critical Windows of Development website tool, which I'll talk about a bit later. So we're supporting the work of scientists and educators as well. So now if you go to the second slide. Today I'm going to start out with science and then talk about regulations and policy and end with a word on prevention. And I want to mention that the slides were designed primarily to be a resource. So there are references and web links for you to follow up on, but they aren't really necessary to follow the presentation with the exception of 2 or 3 slides where you may be a little lost. But we'll try to keep everyone on track. So let's begin with the state of the world today. In terms of human environmental health, it is clear that our air, water, soil, and our very own bodies are all contaminated with chemicals, many of which affect the endocrine system, most of which are made from the byproducts of processing fossil fuels. There is certainly ample evidence that wildlife are suffering the effects of these chemicals. You can read about this in Rachel Carson's book, Silent Spring, and also in our Stolen Fuel and Pete Myers, as well as any number of other scientific publications. So let's go to slide 3. When it comes to human health, population-level statistics reveal rapid increases over the past few decades in many diseases and disorders related to the endocrine system. These include disorders of the central nervous system, such as autism, attention deficit hyperactivity disorder, Parkinson's and Alzheimer's disease, male and female reproductive disorders such as infertility, endometriosis, hypospadias, testicular, prostate, and breast cancers, and metabolic disorders such as diabetes and obesity, and also immune conditions like asthma and numerous autoimmune disorders. The increases are happening too rapidly to be explained by genetic inheritance alone. It must be something in our environment. The evidence to date points to the increase in the last century in chemical production and use, which over the past few decades has followed a similar trajectory as the increases in diseases and disorders in the human population. In particular, chemicals that affect the endocrine system are suspect because they can exert their influence at very low levels of exposure, sometimes called ambient exposure. Slide 4. It is now general knowledge that endocrine-disrupting chemicals, or EDCs, are present in our homes and automobiles, our cleaning products, cosmetics, and clothing, even in our children's toys. We swallow, inhale, and absorb through our skin plastics, pesticides, fire retardants, exhaust fumes, fragrances, and much more every day. EDCs have been found in people's blood, their urine, stools, saliva, tears, and perspiration. They are found in human placenta, in umbilical cord blood, and in the meconium of newborn babies. Bisphenol A, a highly tested poster child EDC, is found in 95% of Americans, even though it's metabolized and passes quickly through the body. And sadly, the levels of many chemicals, including EDCs, are higher in children than in adults. Now, in order to understand EDCs, you have to know a little about the endocrine system. So let's go to slide 5. The endocrine system is the body's chemical messaging system, and the chemical messengers are hormones, which are extremely powerful. When people think of hormones, they often first think of premenstrual syndrome and moodiness. Then, of course, there's puberty and all the changes young girls and boys go through, their complexion, body odor, hair growth, voice changes. Menopause, or more specifically perimenopause, is another well-known life stage during which hormones demonstrate their power and wide-ranging effects, changing metabolism, weight, body temperature, all very basic life functions. And of course, anyone who's ever been pregnant can tell you what hormones do to a body creating another human being. These functions of the reproductive system are mediated by hormones like estrogen, testosterone, and progesterone. But not many people realize that insulin is a hormone. And neurotransmitters, the chemical messengers in the brain, many of those are hormones too. The thyroid functions within a broad network of hormones that influence brain development, heart rate, lung and blood functions, bone growth, metabolism, and even some immune processes. And the endocrine system is optimized to respond to minute changes in hormone activity. In other words, hormones function at extremely low concentrations, in the range of parts per billion or even parts per trillion. 1 part per trillion is roughly equivalent to 1 drop of water diluted in 20 Olympic-sized swimming pools, or about 3 seconds out of every 100,000 years. It takes only 200 parts per trillion of estradiol, an estrogen, to stimulate the brain to initiate ovulation. Slide 6. As many of you know, the endocrine messaging system is typically described as functioning like a lock and key, where a specific key or hormone fits or binds to a specific lock or a receptor. Locks or receptors are located all over the body, not just in the ovaries, testes, and thyroid glands. They are in organs, glands, tissues. There are even hormone receptors in your bones and your heart. The keys, or hormones, can fit many different locks, and the locks, or receptors, can accept many different kinds of keys, although some key and lock combinations work more readily than others. Studies of receptor binding show that in some cases only a few receptors need to be filled by a hormone to turn on the system. Studies also show that when a system is overloaded with an unusually high level of hormones, it may not respond at all. There are several mechanisms by which it does this. For example, it can act like a shutoff valve to avoid a toxic overload. Slide 7. What makes EDCs unique from other chemicals is that they are so similar to natural hormones. The two big issues are dose and timing. First of all, when an EDC binds to a hormone receptor, it competes with the ability of the natural hormone to bind to that receptor. Depending on the EDC, it might occupy the receptor and block the normal hormone effect, or it can mimic the effects of the natural hormone, or it can cause a different effect, even an opposite effect of the natural hormone. EDCs can also affect the creation and metabolism of natural hormones. Slide 8. One hallmark feature of EDCs is that, like hormones, they operate at very low concentrations, so scientists find effects of EDCs using very low chemical doses. Determining what is really a low dose for a particular chemical is tricky. Sometimes it is defined simply as a dose that is lower than doses typically used in government testing protocols. This is because government testing protocols look for toxic effects of chemicals using relatively high doses. Low dose has also been defined as doses in the range of typical human exposures. For most chemicals, however, we have no idea what typical human exposures are. And in order to compare doses delivered in a laboratory to human exposure concentrations, one must understand for each chemical how the delivered dose compares with the actual internal serum concentration of the chemical, based on how it is metabolized and stored in the body, and how those processes differ between laboratory animals and humans. Another point is that EDC effects demonstrated in low dose ranges can be very different from effects seen at higher doses. For example, studies of a relatively high dose, 27 parts per million, of tributyl tin oxide showed developmental effects like cleft palate and other structural deformities. Another study at much lower doses, 100 parts per billion, showed that tributyl tin oxide made stem cells more likely to differentiate into fat cells. Obviously, those are two very different effects at two very different dose concentrations. And then there is the middle dose range, or the no-effect zone. These are doses that are too low to be toxic, but too high to be within the normal range of hormone functioning. This is the dose where the body's shutoff valve may kick in, or where other mechanisms prevent the body from responding to the EDC. Here's a simple analogy to explain how there could be an effect at a high dose, no effect in the middle range, and an effect again, even maybe a different one, at a lower dose. This, by the way, is called a nonlinear or non-monotonic dose response curve, if you've seen that in the literature. So think of your email system, the system of sending messages. Imagine a friend of yours, one who typically sends you an email every now and then, suddenly sends you 1,000 emails in a row. What would happen? It might crash your computer. Like with a high-dose effect, it's toxic and your computer is dead. What if instead she sends you 10 emails in a row? You might look at that out of the corner of your eye and say, something funny is going on here. I'm not going to open even a single one of these. You delete them all and she gets no response from you. That's a no-effect level. But what if she sends just one email, like you get from her on any normal day, and it says, hey, check this out, and you open the attachment? Nothing there. You go on about your business, sending emails, checking Facebook, writing notes, paying bills. Over the course of the next few days, weeks, months even, your computer starts to slow down. It gets cranky and programs are crashing. You take it to your computer repair person, and they say, I don't know what happened, but I'll see if I can fix it. You never in a million years would suspect that attachment from your friend. This is the problem with endocrine disruption. Often by the time your body is failing and you go to a doctor, there's no way to trace the source of your problems back to the initial insult or exposure, which might have happened over the course of your lifetime, or could have been from prenatal exposure during development in your mother's womb. Which brings me to prenatal exposures and slide 9. Like hormones, EDCs exert powerful influences when a body is developing in the womb. The majority of what is known about prenatal effects of EDCs comes from laboratory animal research, because obviously pregnant women cannot purposefully be exposed to EDCs in a controlled experimental setting. So when scientists study EDCs, they typically administer EDCs to pregnant rats or mice and evaluate effects in the offspring. When exposure occurs during certain critical periods of development, often in the very early weeks of pregnancy, normal development of the offspring is affected. And in the research that measures prenatally exposed rats and mice in adulthood, it has been demonstrated that the effects can be permanent. It has also been demonstrated that EDC effects can be carried on through multiple generations of offspring. Slide 10, please. Now this is where the slides are a little complicated, but I think most of you should have them in front of you. I'm going to talk a little bit about TEDx's Critical Windows of Development website tool, which was designed to illustrate how this type of animal research is relevant to human development. It is a web page depicting a horizontal timeline of events broken into weeks during normal human prenatal development, from fertilization to birth. It is also broken out into rows for each of the different life systems: nervous system, reproductive system, endocrine, immune, and others. Each developmental event is represented by a black triangle on the appropriate point in the timeline, and it can be clicked for a description of the event. For example, clicking on a triangle at week 3 tells you that this is when the human embryonic thyroid is first visible. Next, you can look at chemical effects. Currently, we've mapped BPA, dioxin, phthalates, and chlorpyrifos. So if you go to slide 11, you'll see that you can choose a chemical by checking in a box in the upper right corner. In this example, we checked BPA. Then the blue bars turn red to show where and when BPA has effects in laboratory animals when administered at specific time points in rodent prenatal development, which is aligned on the timeline with human development. So when you click on a colored triangle, you get a pop-up box for each study showing results, study methods like dose, timing, and duration of exposure, and the reference. When you look at the results boxes, you won't see words like cancer or infertility or attention deficit disorder. But you will see things like increased mammary lesions, decreased sperm count and motility, and increased spontaneous motor activity. And you will see effects of a single chemical across many different systems, like you see here with BPA, the reproductive, neurological, immune systems, etc. Now slide 12 is just a close-up to show how you can zoom in on a particular system and to give you a closer look at the results box. Most people are amazed at how early in development EDCs exert their influence. Most of the studies have looked at a time period in rodents that is comparable to the first 8 weeks of pregnancy in humans. This is the time when stem cells, which can become anything, begin to differentiate into what they will eventually be: a heart cell, a thyroid cell, a fat cell, a skin cell, and yes, a germ cell. Germ cells are the cells that eventually become eggs in females and sperm in males. One thing I like to tell people, because most people have not thought about it this way, is that you were in your maternal grandmother's womb. That is, the germ cell that became you developed inside your mother while she was an embryo in her mother's womb. So think about that for a minute. The half of you that came from your mother began in your grandmother's womb. When scientists expose pregnant laboratory animals to EDCs, in order to study the multi-generational effects in offspring who were never actually exposed, they have to look at the third generation, not the parents that were dosed, not the first generation that developed in the womb during exposure, and not the second generation that were germ cells during exposure. They have to look at the great-grandchildren, so to speak, of the exposed animals to get an unexposed generation. And yes, they do find effects in that generation. Now back to the critical windows of development, I just want to mention that it has turned out to be an extremely valuable tool with many different applications. It's been used by scientists testifying on health effects of BPA, by NGOs campaigning against chlorpyrifos, by researchers designing studies and writing grant proposals, and by many different professors teaching graduate and undergraduate students about endocrine disruption. By the way, a very small victory was had in the fight against chlorpyrifos recently. EPA announced yesterday that it is instituting new requirements to reduce spray drift. Unfortunately, they did not see fit to revoke any tolerances or cancel any registrations at this point in their registration review. So it was a very small step, but it is going into effect immediately. So the critical windows of development is freely available on TEDx's website, and I would encourage all of you to take a look at it if you're not already familiar with it. Slide 13. Now I want to talk about what's new in endocrine disruption. Some very interesting evidence for endocrine disruption is coming from studies of very early endpoints in development. And I'm sorry I didn't have time to get some references in here, but if you're curious about these, you can email me. In these studies, the parent, rodents of course, the parents are exposed prior to conception, and endpoints are measured at the very earliest stages of development when the organism is still just a single cell or a small group of cells. This is an extremely critical time because cell lineages are established early in development, and they're remembered, so to speak, through many cell divisions. The impact of parental exposure experiences can be carried on from this stage through cell differentiation into tissue and organ development. Studies like these also have implications for public health. They demonstrate just how important preconception health is, and not just for the mother, but for the father as well. The health of men of reproductive age is very important to the future of their offspring. Another relatively new area of research is the discovery of obesogens, chemicals that promote obesity. There are about 20 known obesogens at this point, which tend to be the well-known chemicals, BPA, phthalates, organotins, perfluorinated compounds, that are all pretty pervasive in the environment. Obesogens can operate by activating a receptor called the PPAR-gamma receptor, which regulates fat cell development. They've been observed to cause more and larger fat cells and to predispose stem cells to become fat cells. Like other cells, fat cells are programmed early in life, and obesity has close connections to more traditional endocrine glands and organs. It's been shown to alter female reproductive physiology, hampering the ability of obese women to reproduce. The immune system is another system that must be evaluated under the umbrella of endocrine disruption. Immune cells are exposed to environmental toxicants regardless of the route: absorption through the skin, ingestion and digestion through the gastrointestinal tract, inhalation through the respiratory tract. A lot is known about how the body reacts in the immediate term to acute exposures: skin rash, nausea, breathing problems, neurological effects like dizziness. But very little is known about how the immune system deals with low-level and chronic exposures to EDCs that occur through the same exposure routes. While there is a lot of attention on immune suppression these days, inappropriate inflammation of the immune system may very well be the leading cause for immune dysfunction. Pesticides, metals, plastics all have inflammatory effects, and no two effects appear alike. It's also well known that the developing immune system is particularly susceptible to EDC effects, and as you can imagine, it's critically important for the immune system to be programmed properly in order to respond appropriately to future EDC exposures, as well as infectious agents, allergens, and tissue damage. Slide 14. Important new contributions to the study of endocrine disruption are coming from epidemiologists as well. For example, one of the most interesting opportunities I know of is the Child Health and Development Study, which began in the 1960s, with blood samples collected from something like 15,000 pregnant women and their male partners. Amazingly, the samples are still available, and there is a pretty respectable multi-generational follow-up rate, now approaching the 4th generation. Databases like these are and can be mined to explore any number of hypotheses. Results can then be followed up with laboratory animal studies to confirm observations from the epidemiological data. More of this kind of pairing of human epi data and animal lab work could be extremely valuable to understanding the multi-generational effects of EDCs. Additionally, some very interesting research is being conducted in Europe on combinations of environmentally relevant levels of individual chemicals. This is much more similar to what people experience in the real world than is the study of single chemical effects. Computer models are being employed to predict outcomes, and one goal is to develop biomarkers of cumulative exposure, that is, endpoints that indicate specific exposure combinations. These can then be used to predict disease-based outcomes. What is clear is that we need to use all the tools we have, predictive computer programs, controlled laboratory studies, and human epidemiology to solve the problem of endocrine disruption. Slide 15, please. To summarize, EDCs bind to hormone receptors, operate at low doses or ambient exposure levels, and can appear to have no effects at certain doses, have effects that differ depending on the timing of exposure and are particularly powerful during prenatal development, have permanent effects from exposure during development, have delayed effects that can be expressed later in life, have effects that manifest in subsequent generations, and affect development and functioning of numerous systems throughout the body. This would appear to be adequate evidence pointing toward EDCs as the culprit in the decline in the general health of the human population. The problem is that, as I mentioned, typically the effects of EDCs are not immediately obvious. It's hard to motivate political leaders to address the problem when there is no smoking gun and there are no dead bodies, so to speak, as with the results of acute high-dose toxic chemical exposures. Slide 16, please. And as many of you know, the regulatory system that we have relied on to protect us was not designed, nor is it equipped, to handle endocrine disruptors. Let's look at some of the reasons why the current system is inadequate. Slide 17. Toxicological studies used in regulatory assessments typically measure endpoints such as mortality, organ weight, and gross morphology, for example, deformed organs and obvious birth defects. In order to properly assess endocrine disruption, sensitive endpoints focused on disturbed endocrine function need to be measured in government regulatory studies. This will require the use of different test methods and assays in order to assess endpoints that represent or predict adverse endocrine effects. It is also critical to assess a broad spectrum of possible effects in order to provide reliable information about the potential impact of a variety of different chemicals on the endocrine system. Slide 18. Second, studies used in regulatory decision-making are conducted under the assumption that chemicals follow a linear dose-response curve. That is, that high doses produce big effects, and as the size of the dose decreases, so does the size of the effect, until you reach a dose at which there's no effect. In order to determine safe levels of chemical exposure, regulators take the dose at which there was no effect and divide it by what is called an uncertainty factor, which is typically 10 or 100, to get a much lower safe dose, or what is sometimes called a reference dose or safety standard. So if the no effect level of a particular chemical is 10 milligrams per kilogram of body weight, the safe dose might be 0.1 milligrams. Once a safe dose is determined, regulators attempt to assess how likely it is for exposures above that dose to occur. This is called risk assessment. Notice, however, that with this method, the safe dose is not actually ever tested for its effects. Now think about the endocrine system and how it is designed to respond to very subtle stimuli. Academic studies using very low-dose exposures, measuring sensitive functional endpoints, show effects of EDCs well below the no-effect dose and even below the safe dose. This is sort of scary when you think about it. The assumptions and calculations used to tell us what chemical exposure levels are safe may actually have done the opposite. Ultimately, for many EDCs, there may be no safe dose, particularly for in utero exposures, which makes the process of risk assessment inappropriate for EDCs. Slide 19, please. The third point has to do with why these academic studies are rarely used in regulatory assessments. The current regulatory system gives priority to studies conducted using GLP guidelines. GLP stands for Good Laboratory Practices. GLP guidelines dictate quality control standards for things like data collection, animal care, and equipment and facility maintenance. These guidelines were developed in response to serious breaches of scientific conduct by commercial labs that provide information to regulatory agencies for industry. When testing chemicals for their safety, commercial labs used by industry now must follow GLP guidelines, which are expensive and time-consuming. They also typically use large numbers of animals and measure traditional toxicological endpoints that are insensitive to endocrine disruption. Slide 20. Independent academic researchers are funded by grant sources that do not require GLP, which would add considerable time and expense, that require the use of the absolute minimum number of animals needed to find an effect, and that rely on rigid peer review standards as evidence of good research practices. Academic scientists are conducting research for entirely different purposes than regulatory scientists, and are often developing and exploring cutting-edge scientific techniques with innovative laboratory and analytical tools. Unfortunately, these studies often get eliminated from regulatory assessments due to the lack of GLP. Given the value of this research to understanding the phenomena of endocrine disruption, it is imperative that independent academic studies be included in regulatory assessments. Slide 21. The Endocrine Society has published a definition of endocrine disruptors stating that they are chemicals that interfere with any aspect of hormone action. Today, it's not unusual to see a chemical referred to as an endocrine disruptor in the scientific literature. In contrast, government regulators are struggling to create an operational definition of an endocrine disruptor. The two are worlds apart. Why? Because for a regulatory agency to state that a particular chemical is an endocrine disruptor, it has to be prepared to defend that decision to industry stakeholders and government policymakers. Regulators need rules defining how decisions are made, things like decision trees and checkboxes to prove to industry how they arrived at their conclusions, and their methods must be validated, which takes a tremendous amount of time. So the challenge is to find a process with enough structure to differentiate EDCs from non-EDCs, one that can account for all the unique features of EDCs that I've described, and also enough flexibility to incorporate the rapidly advancing pace of scientific discovery. At this time, it's unclear whether the current system can be modified to handle EDCs or whether a completely new set of procedures needs to be created. Slide 23. Did I miss one? I think we're on slide 22. Let's get a little more specific now. In the U.S., the program that addresses EDCs is the EPA's Endocrine Disruptor Screening Program, the EDSP, which is governed by the Food Quality Protection Act and the Safe Drinking Water Act. So it is primarily focused on pesticides and drinking water contaminants, although it has the authority to assess other chemicals on a case-by-case basis. In June, EPA released the EDSP Comprehensive Management Plan, which describes the status and proposed plans through 2017. 2 lists of chemicals have been issued so far for a total of about 200 chemicals, which I believe are all pesticides. Test orders for those chemicals are currently being issued and reviewed by EPA, and they have plans to issue a list of drinking water contaminants in 2013. Chemicals are prioritized for these lists through the EDSP 21 work plan, which integrates in silico or computational models with in vitro molecular high-throughput screening assays. This allows them to quickly assess a large number of chemicals for basic endocrine activity. One problem is that this system does not address the wide-ranging effects of EDCs. It will miss chemicals that have effects outside the narrow scope of estrogen, androgen, and thyroid activity, for example, like obesogens and immunogens. It will also miss many important chemicals that are already considered in the scientific literature to be endocrine disruptors, such as PCBs. Now we're on slide 23. Scientists, many of whom were involved in the discovery of endocrine disruption, are working to address the problems. The Endocrine Society recently published a statement describing how the principles of endocrinology should be incorporated into regulatory science. The Society statement very clearly states the reasons why EDCs cannot be evaluated like other chemical contaminants. It stresses the need for a new battery of testing protocols and provides recommendations for improving the system. Similarly, the recent paper on low-dose and nonlinear dose responses authored by a long list of eminent endocrine disruption researchers provides specific advice on how to conduct research on EDCs. And just last week, EPA's Office of Research and Development announced that it was launching a work group to address the issue of nonlinear dose responses. Unfortunately, the first research question is if they actually exist. So they're starting at square one. But beyond that, the plan is to assess whether adopting a system to capture nonlinear responses would affect the ultimate conclusions made using the current system of risk assessment. The work group is expected to draft a position paper in the next 6 months to be reviewed and published within a year to a year and a half. Slide 24. I want to talk briefly about the European Union. The EU has laws regulating pesticides and biocides, and it has REACH, which regulates industrial chemicals and consumer products. Although no chemicals have yet to be regulated under REACH strictly for being endocrine disruptors, the EU is a little further along than the US in trying to address the challenges that EDCs pose to their current system of evaluating chemicals, which are much the same challenges as in the US. Most significantly, for pesticides, in the EU they are moving to a system whereby a chemical can be regulated based on its hazardous properties alone, without having to consider exposure scenarios using risk assessment. This is definitely a step in the right direction. The EU also commissioned a study that was recently published, a review of the current state of the science on endocrine disruptors. It thoroughly outlines the questions on the table and also proposes some possible solutions, although the solutions outlined will require a tremendous amount of work to bring to fruition. Questions include whether the reversibility of effects should be considered, whether potency of a chemical is relevant, and if so, how to define it without using dose thresholds, and of course how to account for timing of exposures. Suggestions have also been made that chemicals should be grouped based on effects on the same endpoint, or at least the same system, and evaluated together. The benefit of this is that it avoids the one chemical at a time approach, which will be virtually impossible to do properly for the 100,000 plus chemicals in commerce today. In both the US and Europe, weight of evidence approaches that consider all the available evidence are being proposed as an alternative to risk assessment, but thus far I don't think they have been defined with much specificity. Slide 25. There are some good collaborations underway. The European and US regulatory bodies are collaborating on prioritizing and screening chemicals, as well as test method development and validation. And governmental bodies, like you see on the slide, are sponsoring international meetings to bring together the academic scientists and regulatory scientists in order to address some of the problems I've been describing. The meeting shown on the slide, to be held in Berlin this fall, will bring together basic researchers and government risk assessors to discuss how to address low-dose and nonlinear effects in the context of regulatory science. Slide 26. When it comes to the policy that governs these regulatory programs, there really isn't much good news. But here's a rundown of the legislation I'm familiar with. Congressman Jim Moran and Senator John Kerry introduced the Endocrine Disrupting Chemicals Exposure Elimination Act to facilitate cooperation between the NIEHS and regulatory agencies like FDA and EPA so that the latest scientific methods and results could be used to inform regulatory efforts. Its current status is that it was referred to committee more than a year ago but has not had any further activity. And the Safe Chemicals Act, as many of you know, was introduced last year by Senator Lautenberg to reform the Toxic Substances Control Act. TSCA instructs the EPA to regulate industrial chemicals and consumer products, and so has the potential to be a valuable tool to address EDCs. Unfortunately, although the Safe Chemicals Act has some very important new features for chemical reform, it does not address the need to revise the way chemicals are assessed for safety, particularly with regards to EDCs, for all the reasons I've just described. In addition, the language in the bill refers to safety standards as if the standards exist for most chemicals, when in fact they don't. So I was going to say something about the status of TSCA reform, but I think Diana already gave you the update that the very exciting news for TSCA reform, that the Senate Committee on Environment and Public Works is expected to vote on a new version of the Safe Chemicals Act today. So we'll know very soon what the next steps are for TSCA reform. Now, the Endocrine Disruptor Screening Enhancement Act was introduced by Senator Markey, who's been a great champion of endocrine disruption. This bill would improve the screening of endocrine disruptors by amending EPA's Safe Drinking Water Act. Senator Markey has also introduced legislation to ban bisphenol A in food packaging. Unfortunately, both bills are still sitting in committee a year and a half after introduction. And as far as I know, the FDA, which regulates food, drugs, and cosmetics, has no broad legislative efforts to address EDCs. Any progress through the FDA will have to come on a case-by-case basis. And if a case is defined as one chemical in one or two specific products, like last week's ban on BPA in baby bottles and sippy cups, you can just imagine how long it will take to get EDCs out of consumer products. And don't be fooled by apparent successes like this FDA ban, which was actually prompted by the American Chemistry Council after they had already taken BPA out of baby bottles and sippy cups. It actually undermines the overall cause by giving the false impression that BPA is safe for other uses. Ongoing state and local efforts are putting pressure on industry as well, particularly with regards to BPA. At least 11 states now have bans on BPA in children's products. And California's safer consumer product regulations are worth keeping an eye on. The regulations first require the development of a list of chemicals of concern. Any company that manufactures, imports, or sells products that use chemicals on the list will have to justify their use. If they cannot, the company will be placed on a public failure to comply list, and the product will be banned from sale in California within a year. I don't know if development of the list of chemicals of concern will include appropriate consideration of EDCs, but there's definitely potential there for good progress. Maine has a similar piece of legislation, the Kids Safe Products Act, which names priority chemicals and can prompt the phase-out of a product if alternatives are available. Several other states have also introduced legislation that requires companies to perform an assessment of possible alternatives. If the alternatives assessments account for EDCs, then we're in good shape. And now I have to make an extra plug for the first bill I mentioned. All of the other EDC policy initiatives rely on knowing which chemicals are EDCs. The purpose of the Endocrine Disrupting Chemicals Exposure Elimination Act is to help regulatory agencies develop appropriate test methods to identify EDCs. Without this, other chemical regulations may reduce exposure to toxic chemicals, but not necessarily EDCs. Slide 27, please. There is another approach to the problem. That is to motivate chemical and product manufacturers to develop and/or choose to use safer chemicals without being forced to do it through government restrictions and chemical bans. The two areas where this is happening are green chemistry and alternatives assessments. Green chemistry is the science of designing molecules to be intrinsically less toxic, where toxicity testing is part of the design protocol from the very beginning. Believe it or not, historically most chemicals have been developed with no effort to test or understand their toxicity, with the exception of pharmaceuticals. A new approach is underway to promote assessment of chemicals for their endocrine disrupting properties. It proposes a voluntary protocol for industry chemists to follow so that chemicals can be rated on how well they fare in a particular suite of assays, which can be updated based on the latest scientific knowledge. By changing how chemicals are developed, this system, which is currently undergoing peer review at a scientific journal, could eventually lead to substantial reductions in the overall toxicity of our environment. Slide 28. Somewhat similarly, there are a lot of people working on alternatives assessments, or informed substitution. Alternatives assessments typically come in the form of a database that provides comparisons of chemicals with regards to their health and environmental harm or safety. This allows the end user, whether it's a chemical manufacturer, a product retailer, or a consumer, to choose the safest chemical or product that meets their needs. This way, the public health agencies don't waste decades researching and trying to regulate a chemical, only to have it replaced by an unknown and possibly more hazardous chemical. Right now, there are several different alternatives assessment programs available. Some are focused more on the environment than on health, and some address endocrine disruption better than others. I've put links to them on the slide so you can follow up if you're interested. They are EPA's Design for the Environment, Clean Production Action's Green Screen for Safer Chemicals, and the Healthy Building Network's Pharos project. Slide 29. Some of the alternatives assessments have incorporated TEDx's list of potential endocrine disruptors into their systems, which is also soon to be incorporated into EPA's ACTOR database, which is a warehouse for chemical toxicity data. The TEDx list is a list we developed of nearly 1,000 chemicals with verified citations to scientific publications indicating effects on the endocrine system. It includes pesticides, plastics, food additives, household products, personal care products, and more. And very soon we will be releasing an updated list that will include the uses and sources for each of the chemicals. In addition, we are working on a much more elaborate database of selected EDCs that includes detailed information on the endocrine-related health effects of each chemical, including any human biomonitoring data, production volumes, and other relevant information. We are trying specifically to identify chemicals with widespread exposure that affect a variety of different systems or health endpoints. And many of you know that we've been involved in studying the health effects of the chemicals used during natural gas operations. So in addition to the categories of chemicals described above, we are also looking at fracking chemicals, drilling chemicals, and chemicals used during maintenance of natural gas operations, particularly those that volatilize and become air pollutants. And we're looking at all of these chemicals very closely for endocrine effects. Slide 30, please. And now I would like to say a word or two about prevention. starting with the cost of treatment. In the U.S., looking at current figures, we spend $218 billion a year treating diabetes, $172 billion treating Alzheimer's, and $137 billion treating autism. If you add up all the diseases and disorders on this slide, you get nearly $1 trillion. Nearly $1 trillion just on this set of diseases and disorders, just on treatment, and just in 1 year, and just in the U.S. So think about what this is doing to our economy and the federal budget. And aside from the cost, think of the heartache, the frustration and hopelessness so many people feel every day, unable to communicate with their children, as in the case of autism, unable to communicate with their parents, as in the case of Alzheimer's, dealing with the ramifications of obesity and diabetes, and tending to children and parents who will need constant care for the rest of their lives. Pharmaceutical companies can create all the treatments they want, but we need to put more effort into preventing further challenges to our health and our society. Some of you may know the story of the community that was living along the river. One day, a body floated down the river, and the people rushed to pull the man out. And before they knew what was happening, more bodies came floating down the river, and they kept pulling them out and laying them along the bank, until one lone villager stood up and looked upstream. He started walking away, and everyone shouted, "Where are you going? We need your help." And he said, "I'm going to see what's causing all these bodies to float down the river." Ultimately, that's what we need to do. Stop endocrine disrupting chemicals at their source. Slide 31. I know the story of endocrine disruption is grim. It can be so overwhelming that it paralyzes people into inaction. And it can be easily misinterpreted to indicate that only pregnant women need protection because it's too late for the rest of us. But it is by no means too late to protect ourselves. We know precious little about childhood and adult exposures, how they interact with prenatal exposures, and how cumulative exposures affect us all. The precautionary approach is clearly warranted, and it is up to those in the environmental health field to devise prevention-based interventions, educational campaigns, and other creative ways of helping people reduce their exposure to EDCs. We already know that one of the quickest ways to get manufacturers to stop using EDCs is to stop buying products that have EDCs in them. Consumers can pressure retailers and product manufacturers, who can then pressure chemical manufacturers. Look at what happened with BPA. Governments all over the world are still fighting over whether or not BPA is bad. Meanwhile, when people stopped buying plastic water bottles made with BPA, voila, new bottles came on the market made without BPA. So there are ways that individuals can make change without waiting for politicians and regulatory agencies to figure out how to deal with the problem. My advice is learn more, use less. Some people rail against the need to learn so much just to purchase a product. But at this point in time, we don't have much choice. Our bodies were not designed to handle the chemical soup we are now living in, and we simply cannot evolve quickly enough to adapt to it. Whether we like it or not, we're all going to have to keep learning and keep making smart choices in what we eat, drink, breathe, and put on our skin. It is for our own good and the good of the next several generations to come. Slide 32 is a thank you to all of our foundation funders and individual private donors. And I want to thank the staff and Dr. Colborn for helping me prepare the presentation. And if you need to get in touch with me, if you have questions that aren't answered here, my email address is at the bottom of this slide. So thank you very much.
Thank you, Carol. Can you hear me?
Yes.
Oh, great. Thank you so much for your excellent presentation and for your sharing your expertise with us today. And your presentation is packed with references to resources that people can pursue and learn more, but we have the wonderful opportunity to have you on the line with us today and to take people's questions from the audience. So I would like to unmute the lines now. Just hold on one moment. So in the final 10 minutes of this call, we have the opportunity to ask questions and make comments. And if you'd like to do so, please press *6 on your telephone to unmute your line, and please state your name and affiliation. We also ask that you please try to be brief with your comments to allow others the opportunity to participate as well. So we're ready now for anyone. Just press *6.
Okay. Hello, Dr. Kwiatkowski. This is Fran Solomon from Seattle, Washington. I teach at the Evergreen State College. Thank you for your excellent presentation. You mentioned at the outset a list of diseases linked to exposure to EDCs. One was Alzheimer's disease. Could you share what some of the current information is about how EDCs might be contributing to Alzheimer's?
Oh, that's a very good question. I'm going to actually ask Dr. Colborn if she wants to come on the line and answer that question. I was hoping she would be available. Her head is in the latest and greatest science, and I wonder, Theo, if you know the answer to this question, specifically for Alzheimer's disease.
Well, am I on?
Yes, you are.
Okay, Carol, what I would suggest is that we already have compiled data on this, and it's sort of in a little package. Why don't we just offer to get that up on the website within a day or two? Oh, let me see, Ashley's away. Oh, dear, and Carol's out. Okay, we've got a problem here. Our two gophers who pull this information out for us are away. Can you give us a week?
Yes, if you get back to me, this is Diana, with any additional resources that you would like to make available to participants, I will send them an email announcing when those are ready and where they can find them.
Oh, good. Thank you.
And I would also ask the woman who asked the question, you're welcome to email me as a reminder, and then I can send something directly to you.
Great. Thank you very much.
This is exactly the kind of question I was afraid of that was really going to draw on very specific, detailed information.
Okay. So, thank you.
Would someone else like to ask a question or make a comment?
Hi, this is Jim Heinzman. I'm representing the ITRC as a national stakeholder for sediments cleanups. And we have a guidance document that we're currently writing. And in terms of the Great Lakes region, I live in Michigan, we have endocrine disruptors in every one of our Great Lakes in levels that warn people not to eat fish, especially pregnant women. Now, we have a tremendous source of contaminants that are in the sediments in this entire watershed. Are you guys working on these issues that bring these into the food chain, not just pesticides and agricultural and FDA? What about sediments? What about fish consumption? These types of issues. I'm trying to get the point across that every one of these bioaccumulators is soluble in parts per trillion, and the idea is we think we can make them attenuate. Not my idea, but the regulated community thinks they can attenuate, be buried, and they will go away. But if it continues to dissolve at parts per trillion and get into the food chain, that is not the answer.
I totally agree with you, and it's really a terrible problem because we don't even have the tools to test for these things, much less to figure out how to get them out of the water sources or the food chain. And I would say we're paying attention to this issue closely, but it's just one of those outstanding problems.
We have enough of it in Lake Superior right now to cause, fish warnings. Lake Superior will not turn over once for 500 years. So it's going to take that long to flush Lake Superior once. Lake Michigan, 180 years. And on down the line. And the whole system adds up to over 1,000 years.
I know, and it's not as if we are getting a flush of clean water coming through.
No, that's why I mentioned sediments and it's not just sediments, it's also airborne. But if you're going to flush sediments in the hundreds of parts per million, which we have throughout the watershed in select hot areas, that's an ongoing source forever, essentially. And at the part per trillion level when you dissolve it. And I'm trying to work with this group to enlighten them a bit, say that, no, we have to remove these things, not leave them in place and hope that they will dilute and go away, because they're not. They're not going to dilute.
And I think that...
Do you have anybody in your organization that I might be able to contact further on this? Because I'm writing stakeholder comments right now for this guidance.
Theo? I don't think we have anyone here at TEDx. I could rack my brain for...
Well, I'll send you an email.
For you,
Well,
yeah.
Other people get on the phone here to have their discussions. But do you mind if I email you?
Not at all. Please do.
Well, thank you for your discussion, and I guess I'll move on for the next. Trying to be brief here.
Thank you. We still have about 5 minutes. *6 on your telephone to unmute your line.
Okay, this is Theo again. Do you hear me?
Yes.
This issue was brought up way back in the early 1990s. It was really interesting to hear you talk about, sediment and the possible flushing of these materials and the turnover time in the various lakes. And it just sent chills up and down my spine because all this kind of information was taken to the International Joint Commission. It was taken to, that would be Canada and the United States, to the Canadian agencies, health agencies, and the U.S. agencies. And it's just something that no one wants to address. You just raised the bristles on the back of my neck because it sounded like finally somebody's coming along and proving that we've made no progress on this at all. I'm sorry to be so gloomy.
I have a question.
Can you state your name, please?
Thank you. Tony Trudale. I've identified one issue that is in these OECD chronic test guidelines that are so poor, and along with GLP serve to keep the independent literature at bay, and that's that they sacrifice the animals just as they're reaching old age at about the human equivalent of 60 or 65 years old. And so all the disease latency of chronic diseases is never manifested. So I just want some comment on that.
Yes, there's definitely is. It's just a crime that that potential data is wasted. We're not studying the long latency for these things to show up. And again, I think if we can get some good advice as to how to use these things and what endpoints need to be studied and how long they need to be carried out, that can only help.
We have time for one more question or comment.
Are we still on mute? Hi, this is Jim Heinzman again. Hello?
Yes, please make it brief because we are just about out of time.
Okay, very briefly. Here in mid-Michigan, we're also working on the Velsicol contamination site in the city of St. Louis. We are looking to hopefully get a health study on the problems here. We have several of the endocrine disruptors, and they've been in this community for 80 or 90 years. Any ideas on how we could stimulate somebody to help us out to get somebody to study the population here? PBB, DDT, I mean, it was a huge production problem. This was the plant that produced PBB here in mid-Michigan.
And you're wondering how to motivate your political leaders.
Yes. How do we get a public health study? Because this whole region has dioxin, PBB, and DDT in horrible quantities. We have birds still dying in downtown from DDT poisoning. Mm-hmm. We're concerned.
And I imagine that they've seen a lot of different research on this already. So maybe one idea is to approach it from this angle of endocrine disruption and what's unique about endocrine disruptors and their, at low concentrations, the types of effects they can have. Instead
of risk, right? Because you mentioned risk is a broken record in terms of this. So let's go for endocrine disruption study.
Exposure levels are not relevant to the conversation about endocrine disruption.
Right.
You could send them the MP3 of this talk, maybe.
And that is an excellent segue because we are out of time. I want to respect people who have another commitment now. So I would like to thank everyone again for joining us. Thank you, Dr. Kwiatkowski, for your time, and everyone at TEDx for all of the wonderful work that you do. I'd like to remind everyone that a recording of today's call will be posted to our website probably by tomorrow, Friday at the latest. Thank you very much again for joining us today, and if you have additional questions regarding the presentation, Carol did provide her email address on the presentation slide. You can contact her directly. If you have more questions about the work of Alaska Community Action on Toxics or about these Alaska Collaborative on Health and the Environment calls, please call our office at 907-222-7714, or you may also email me at diana@akaction.org. And thank you again to everyone.
Thank you.
Thank you.
Thank you.
Bye-bye.